Hello everyone. Uh, I would like to continue with you the surveying tutorial. First of all, we have solved in the class the calculation concerning this the leveling of this traverse using a correction method. The results using compass method are given. The corrections are given using these formulas, and we have adjusted the values of the different elevations of B, C, D. And after this, we pass it to exercise number 2. So this is exercise number 2. A surveyor with his theodolite and tape have measured the angle at two different positions. The angle between the horizontal and the highest point of this building. This is a very high building, by the way, but just I've just found this photo. So the first angle was alpha. Alpha is equal to 45 degrees. After this, he made a translation with the distance AB equal to 50 meters. And take another shot of this elevation at this point, and he found the beta equal to 35 degrees. The instrument height was set to 1.5 meter, and the objective is to find the elevation of the building. Okay, find capital H as a function of AB of HI, the elevation of the instrument, the angle alpha and beta. If you remember, there's a slide in our course. In this slide, they are showing an exercise made in the, I think in this 18th century to measure the height of a mountain in Japan. This is the same logic in reality. So to solve this, let's try first to express H as a function of HI, alpha, beta, and AB. This is our building. This is the situation exactly. So in reality, if you take this if you take this I don't know if I can come back. I can't come back. Okay. Uh, so if you look to the building, this is the H, the elevation H of the building. So here we have H minus HI, and we have here an angle alpha, a certain distance D. Here we have a distance AB, and normally using this first triangle, we are able, and this second triangle, we are able, okay, second triangle is AB plus D horizontally, and here you have H minus HI, and you have an angle beta. Normally here the tangent of the angle alpha is H minus HI divided by D. This is H minus HI divided by D. And here you have H minus HI divided by D plus AB equal to tangent beta. Okay, so starting from these two equations, I will be able, because these two equations are independent, I will be able to calculate capital H, the height of the building. So the H minus HI divided by D is equal to tangent alpha. H minus HI divided by D plus AB is equal to tangent beta. I rewrite this equation like this: D equal H minus HI divided by tangent alpha, and I put D plus AB here is equal to H minus HI divided by tangent beta. Now I can replace D in this second equation. So if I replace D in the second equation, I found the following equation. This following equation, maybe I can put the capital H together, and the other elements from the other side. And normally I will found this relation that can be rearranged like this. So now if you write this, you will have at the denominator tangent tangent beta. Here you will have tangent beta minus tangent alpha, and you will be able to rearrange this. If you rearrange this equation, you will have capital H is equal to HI plus AB multiplied by tangent alpha cross or multiplied by tangent beta divided by tangent alpha minus tangent beta. Numerically, if you replace it, you will find that 1.5 plus 15 cross tangent alpha minus cross tangent beta divided by tangent alpha minus tangent beta. You make your calculations, you will find this value. So this is for the exercise number 2. It is a basic exercise. Normally, it should not take more than 15 minutes to do it. You have to avoid errors when you make your calculations, and everything's gonna be okay, inshallah. Next, this exercise was given in the class, but let's do it again together with the new values. With the new values, here the angle is given in degree. So if the angle is given in grad, you have to, or in gon or grad seems the same, means the same thing. You have to take care about this. Now, the first question. So you have what we call trigonometric leveling, means that you have installed your instrument here, and you want to shot the point B. Since it is there's a distance, we put in general reflector or rod to measure this height r. Okay, so the idea or the objective of this question is to establish. And when they ask you to establish, this means that you have to prove the relation. Okay, so you have to write the relation, you prove it. This is the first question. After this, you have to calculate delta AB numerically, delta AB, which is the difference in elevation between A and B. Okay, and at the second, on the question 3, they gave you the different errors, and error on HI, error on S, the slope, error on Z, the angle given by the theodolite, and an error on the reading on the rod, which is equal to 3 millimeter, and they are asking you to calculate the total error on delta AB and calculate this numerically. Okay, so let's move now to the calculations. If you take delta AB plus R is equal to HI plus V. This is my first relation. This relation link delta AB, difference in elevation between A and B, R, HI, and V. I have to replace B by by something in relation with S and Z. So if I take this triangle, I have V divided by using Z, V divided by S is equal to cosine Z. Now, if I replace this, I will have delta AB equal to HI plus V minus R. I replace V by S cosine Z, and I have finally this relation. Numerically, I will write that delta AB is equal to 1.60 plus 150 cosine 70 degree. The cosine should be calculated in degrees. Minus 1.25 is equal to 51.65 meters. And here we have two significant numbers as given by the exercise. Let's move to the error calculations, and the error calculation would be based on this relation. Okay, now let's do the calculation. We have delta AB equal to HI plus S cosine Z minus R. Delta AB is a function of HI, S, Z, and R. The error will be calculated like this. Okay, so the error on delta AB is the square of the partial derivative of AB over HI squared, EHI squared, partial derivative of delta AB over S squared, ES squared, delta AB over Z squared, EZ squared. And here you have to take care that EZ should be written in radian. And it is better to convert all this in SI, in meters, even the errors. And delta AB by the derivative by R squared, R squared. So if you do this, d delta AB, this is my equation. The partial derivative of AB over HI, you have 1 over S, you have cosine Z, over Z, you have minus S sine Z, and over R, you have minus 1. Normally, if you have your errors, it is better to replace them here. It is 0.005 here. Maybe I have a pen. Here we have not this, but 0.005 in meter. Okay, so ES 10 centimeter, I replace it in meter. ER 3 millimeters, I convert it in meter. And the angle, which is error on angle, which is 15 seconds, I replace it to 15 by 3,600 in degrees, multiplied by pi over 180 degrees. It will give you the value in radian. This is my value in radian. Okay, so the error in delta AB would be this value. Okay, so finally, this is my final, after calculation, this is my final result, which is equal to 12 millimeters. Okay, here the calculations are given with an accuracy of with three significative numbers. It means that you should truncate your results to the millimeter. Okay, thank you very much, and I can see you in the office hours if you want to tomorrow.